Hello, everybody. Welcome to Guru Talks with IIT Madras Alumni Association. I'm Jaipriya, and I'm really happy to host Professor Manu Santhanam from Department of Civil Engineering, IIT Madras. He needs no introduction today, but let me just give you a short bio of what he has been and how he has come about with this kind of a thing, and what are all the accolades which we have received because of this particular innovation which we're going to be talking about today. So Professor Manu Santhanam is in building technology of construction management division, and he currently heads the Department of Civil Engineering in IIT Madras. Alumnus of IIT Madras, 94 batch. He's joined then Purdue University to do his master's and then worked there for a while, came back to his alma mater in IIT Madras, and he's been here as a professor since 2009. Um, with Mr. Aditya Jain. We have Mr. Aditya Jain also here, who's again an alumnus of IIT Madras from 2016 batch. They both have come together as a association and they've created something fantastic called as 3D printed houses. So there's this saying in Tamil called Vite Kattipar Kalyanam Pannipar, which roughly translates to, you know, celebrate a wedding or build a house. It's that difficult. It's supposedly a Himalayan task. And if we construct a traditional house, it costs anywhere between 1,600 to 2,000 rupees per square feet and takes anywhere between 8 to 18 months to get it done. So what this team has done with the other two co-founders of Mr. Aditya Jain is that they have constructed this 600 square feet house within 5 days, and they promised to construct houses within 3 weeks. So how amazing is that? Let us listen to Professor Manu Santhanam, where he is going to be explaining about this particular concept of 3D printing and how they came about with this idea and how they put India on a map. To give you a context, we are only one among the 3 countries who have done this 3D printed houses, of which one is Netherlands, which was the first one. Second was USA, which had actually a mixed material printing. But then India, I think this is purely a 3D printed material houses, right, sir?
Well, yeah, mixed, but yes, we are one of the few countries which have done that. Yeah.
Okay, over to you, Professor. Please carry on.
Thank you, Jaipriya. So, hello to everybody, all alumni all over the world. I hope that you're watching and giving us encouragement, sitting in different corners of the world. I'm very happy to share with you our experiences with building India's first 3D printed house. Hopefully, a project that will pave the way for many others in the future, and something that will help us revolutionize the current construction industry. So without further ado, let me share my presentation. So I've tried to not make it too technical because I know that there's going to be a lot more general audience, not specifically civil engineering audience out there. But most of the things related to construction of the house are things that people are well aware of in terms of what you really need to go through, as Jaipriya had put it earlier, to really get a house constructed. So many of those things you'll probably identify and understand. And many of you are in different high-tech positions and doing a lot of high-tech stuff. So all of you probably know the significance of what 3D printing has to offer in other kinds of industries. So in construction, there's a lot of impact that 3D printing can do. And hopefully from this presentation and the ensuing discussion, we can have some idea about the future, what it holds in terms of application of this technology in the construction industry. So let me share my presentation here. Right. So, as Jaipriya had pointed out, at IIT Madras, we have undertaken this journey on 3D printing along with this company called Tvasta Manufacturing Solutions, which is today represented in this forum by Mr. Aditya. So together, IIT Madras and Tvasta have come together to make this imprint or IIT Madras Printability Lab, which is essentially responsible for all the work that you're going to be seeing in this presentation. So we have been working together. Although this is Guru Talks and it features me, but I think the real gurus in this case have been the youngsters from Tvasta, who have really shown that they can make high-tech projects. They can realize high-tech projects in India, something like 3D printing, which is the realm of a few companies around the world. They have really gone to the finest details and worked out how it can be done in India with our own Indian materials and our own Indian technologies. So the real gurus for 3D printing, as far as Indian construction is concerned, I believe, are Tvasta, the brand of youngsters. They are all, many of them are alumni of IIT Madras, so we have to be very proud of what they've achieved in this short period of time. So I'd like to basically take you through a journey of what we have done together in the subsequent slides that I'm presenting here. So I'm sure all of you are aware, but let me just put the context here. 3D printing is a technique which belongs to this group of techniques called additive manufacturing. Many of us are familiar with the typical machining operations where we take a larger block and do various kinds of operations like milling, turning, grinding, sawing, and so on to cut the shape that we desire for the particular object. In 3D printing, we just build from bottom up. So we basically add layer by layer and essentially build up the entire structure. So in this way, we can actually create structures where we use less material and we are able to build up with minimal wastage of material, and also try and utilize some very interesting properties of these materials that can give us much better control on the kind of structures that we are getting. Now, as far as construction is concerned, there are two major options as far as 3D printing is concerned. One is extrusion-based 3D printing, which is going to be the bulk of what I'm talking about here. Extrusion-based just implies that you're pushing something through a nozzle, and this is getting deposited layer by layer. Okay, so that's basically extrusion-based 3D printing. This can be executed in frame-based systems, as what I've shown here. So you have the X and Y frame, and you have this gantry which is moving on this frame, and the Z-axis which is here, which is carrying the nozzle with it. So the gantry is able to position this nozzle anywhere in this two-dimensional space, and you essentially build up from the ground layer by layer upwards. So that's called a frame-based system. The other option is obviously to have a robot which is sitting in one of the corners or perhaps in the center of the building and simply depositing material all around it. So that's, as you can imagine, a lot more expensive as compared to this frame-based system, which is easier to construct and possibly easier to scale up in terms of an industrial scale application. The other 3D printing operation that is conceivable in construction is that of binder jetting. Now here, what happens is essentially you're creating the object by depositing the ink on a bed of the material that needs to be printed. For example, you can actually create on a mixture of cement and sand together, you just deposit water in the shape that you want the layer to take. And essentially you keep on depositing more and more material like this. Only problem with this is at the end of the whole thing, you need to brush away all the additional material that is on the sides, and this way you end up losing or wasting a lot of material. So as far as large-scale construction applications are concerned, binder jetting is not really an option. You can do a search on this on Google and you'll find all kinds of very interesting shapes and forms being created by binder jetting. But that's more for architectural purposes and does not really hold good as far as long-term construction projects are concerned. Executing the kind of projects that we are going to talk about later in this presentation. So in construction, of course, additive manufacturing or 3D printing gives a lot of advantages. First of all, there's going to be a reduction in construction time and labor cost because you have very little labor, everything is done by the machine. You have the project realized in much shorter time intervals. Jayapriya was quite optimistic when she said we constructed the structure in 5 days. That's our hope, to construct the structure in 5 days. We actually took a lot longer than that. But if you take the actual printing time and the assembly time and calculate the number of hours, probably we are close to that ballpark. The other major advantage is it's formwork free. Many of you may have seen structures being constructed, and you would have seen the inordinately long time it takes for people to put together the formwork to define the shape of the structure. And it still takes a longer time for them to remove it, right? And the cost associated with formwork can also be significant. 30 to 40% of the cost and 60% of the time in concrete construction goes in actually assembling and disassembling the formwork. So that's a significant amount of time and cost saving that you can get by 3D printing. The other major advantage here is because you're not using formwork, you're not really restricted to using shapes that are conceivable by formwork. So you have the flexibility of design and geometry, and which can make it very good for architectural elements. And we can start thinking increasingly about non-rectilinear forms. Typically, we see houses, we think about these boxes, right? But here we can break free from that concept and build something completely different. Now, of course, there are limitations as to what we can do with concrete, but nevertheless, you can realize something which we cannot do with conventional techniques. So again, let me put this in the context at the beginning itself. If we are planning to create more and more boxes like we are used to doing with conventional construction, then 3D printing is not the right option. If we really want to use the benefits of 3D printing, we need to create these forms which cannot be conceived by normal construction. There are several companies around the world which have executed projects in 3D printing. You have companies based in Netherlands, Italy, Slovenia, USA, and one of the most popular companies is this Vitavinian Brothers in Netherlands, and they have created some very amazing structures in Netherlands. And of course, as I said in the beginning, we have our own company, Tvasta, which is from IITM alumni, and they have really done us proud by actually being the first Indian manufacturer of 3D printers for concrete. So this is just a concept that I'm trying to explain here, what you can do with 3D printing. So this is a factory-like setting in which these construction elements are being created. You can see these structural elements being printed by this similar type of a gantry type printer. So it is depositing the material layer by layer. Once this element has been fully deposited, you store it or stack it in the factory. Most of you must be aware that for concrete, in order to gain strength and in order to ensure that the cement properly reacts with the water, we need to cure it for a substantial period of time. Curing simply means keeping the concrete in a moist environment. And that is what you need to do in the factory to ensure that the element gains sufficient strength. Once it's gained strength, you can then bring it to site and assemble it. So this is possibly the way in which we can speed up construction projects significantly. Now, one question that must pop in your mind at this stage is, why is it different from precast? In precast also, we do the same thing. We make the construction elements at the factory, and then we assemble that at site. The difference here is that you don't need formwork. In a precast factory, you need substantial amount of formwork, and a lot of the productivity of the precast factory depends a lot on how fast you can actually reuse the formwork. When can you go to the next stage and so on and so forth. Here, you don't really have that problem. You can continuously print as many as you want, as much space as your factory will allow, and then ensure that you can actually transport all these elements quite quickly to the job site and get them assembled there. Now, several projects have actually been executed mostly in terms of pilot projects or demonstration structures across the world as far as 3D printing is concerned. So this is a very interesting example of a 3D printed house in Moscow done by Apis Core. And you can see here the machine, which is basically a robotic arm, which is depositing concrete all around it and creating this nice circular type of shape, which is not conceivable by typical construction, because then you have to spend a lot of money on shaping the formwork correctly and so on. And such formwork which you create for such special shapes may not be usable again, right? So that's again a waste of money and time in creating this kind of a formwork. These are projects executed by Vincent Global in China, and China is a place where the industry has really pumped in a lot of money and are taking the lead in actually defining the kind of projects that 3D printing should be actually used for. So here what they've done is these smaller houses, they printed components for 10 houses in a single day. So that shows the extent of speeding up or scaling up that you can actually do, because you have now the potential for creating more and more of these units. And all you need to do is ensure that there's sufficient amount of transportation available to carry them to the site and place them. These are projects. This is a project executed by the company called Icon. That's a very nice example of how aesthetically pleasing your structure can be. And of course, on the right, you have a structure that is possibly not important, but it just was made to show the potential for 3D printing for creating unique architectural shapes. So there was a mini castle created by Rudenko, who's one of the pioneers as far as 3D printing is concerned. These are projects executed, of course, on the left in Dubai. It's a municipal building being done by Apis Core again, and you can see the same robotic printer, which is actually printing all around it. Again, the USP is obviously the geometric flexibility. So you have to make use of these circular shapes and integrate them in the design quite nicely. These are a cluster of houses built in Mexico by Icon. again, which is a company which has done a lot of projects, interestingly, around the world. And in fact, today there was a news item that you can actually see if you do a Google news search. You'll find that this news item talks about 7 3D printed houses around the world. So there are several examples around the world. But of course, this is mostly on a pilot scale. Commercial scale projects, as was earlier pointed out by Jayapriya, have been executed in Netherlands and the US. Most of the others are primarily your demonstration or pilot scale projects. Architectural elements, you can see how beautiful this shape looks like, and all this is 3D printed. And furniture, again, another garden furniture could be another non-structural use of this kind of a material. And of course, here in China, they also made bus shelters with 3D printing. One of the uses of 3D printing to create army barracks by the US Army Corps of Engineers was executed from the purpose of actually creating these structures in difficult terrains where you could not get regular construction equipment and manpower to do the construction. And so they were executing this from the perspective of looking at it as a army construction. And you can now, again, you can see the intricacy that can be created with 3D printed designs. This is actually a small security shed that is created by Siam Research and Innovation in Thailand. These are very intricately crafted columns that you can see. These are basically your research that is going on in EPFL, again, in Switzerland, which is a very, sorry, not EPFL, ETH in Switzerland, which is a university which is doing extensive work on architectural aspects of 3D printing. Again, 3D printing has also been demonstrated to be used for bridges. This is a pedestrian bridge built in Madrid. And this is actually a post-tensioned segmental bridge that was executed in Netherlands. So there are opportunities for using 3D printing for several different types of elements. However, our focus here is to look at housing. And this is something that most of you probably are aware of, that our urban population in India is going to be close to 1 billion in 2050. And going by the current estimates, we seem to be heading towards a need of 100 million houses by 2030. We don't have that much time, only 9 years. You might have heard of the schemes that have been specifically created to ensure that we serve the needs of so many different sections of the population by building more and more houses, which is the Pradhan Mantri Awas Yojana. And then this has given rise to a new event that was launched in 2019 called the Global Housing Technology Challenge, or GHTC, which brought together many different potential technologies that could actually help in rapid construction of mass housing in India. Now, it turns out that for the future, one has to start looking towards technologies that will increase the productivity and not really suffer from the same problems that conventional construction does. And this probably gives some sort of a leeway for 3D printing to be a possible solution for India's housing needs. However, you have to realize that once you go with 3D printing, there are further needs for scaling up, and really to take up to the level that is needed for mass housing will take quite a bit of research and development. So why 3D printing of houses? As I said, individual customization can be done. So when you build mass housing, very often we feel that people have created these boxes, right? You have the same box replicated hundreds of times. With 3D printing, you don't have to worry about that, because each of these units can now be customized to the needs of the client. Even though it is affordable housing, they can still customize it because the printing can be done in different shapes. You don't need to recreate the same shape each and every time. You can create structurally efficient forms, because what we are creating here are walls which are mostly empty, which have ribs inside to give some lateral strengthening, but mostly these walls are empty and have spaces for basically acting as cavities. And we minimize the material usage by making the forms more structurally efficient, essentially ensuring that we can carry the same level of load without really having to use extensive amount of material that we typically do on most construction projects. Again, because of the presence of these cavities, we can now create channels for making weatherproofing possible within the structure itself, and also providing utilities within the walls of the structure. So overall construction process becomes a lot more efficient. And again, because this kind of a printer is quite portable and it can be taken to different locations, if you are able to adapt this to the materials that are available locally, then it can be a technology that can actually go to deliver quality houses in several different locations without the need for a proper infrastructure, construction infrastructure available in those kinds of locations. And again, difficult terrains, for example, building for the army, for instance, in difficult to reach locations, that could also be something that could be conceived by executing 3D printing. Now, the question is, are we ready for deployment tomorrow? Now, the straight answer obviously is not, because we are focusing a lot more on pilot projects to kind of demonstrate the limits to which we can go to really create these structures. The challenge in really developing this as a technology for satisfying the housing needs of the country include, of course, automation of the reinforcement placement, because many of you may have seen examples of 3D printed structures across the world which really are made with plain concrete. There's not much steel in there. And those of us who are civil engineers know that steel concrete composite action is really designed for a proper structural load bearing capacity, and also the ability of the structure to resist disasters like earthquakes. So how do we integrate the steel reinforcement in a structure that is made out of this plain concrete? Can we make a robotic or automatic system that places this reinforcement? That's something which we should look at in more detail. Finishing process, of course, many of you have seen examples where these layers are actually visible from the outside. You'll see that in our house, we don't have that. We have nicely plastered the walls to make it look like an ordinary or normal house, so that people don't really have the idea that they're looking at something completely different. However, to realize the benefits of using this kind of material, one has to be able to use the structure as is without the need for plastering. And there we need to look at finishing processes. Printing horizontal elements like roofs, foundations, and other slabs, for instance, could be a challenge, because you're basically wasting your time by depositing material horizontally. So can we look at creation of formwork on the edges and dumping the material normal concrete inside? That can speed up the construction process significantly. So 3D printing is really viable mostly for the vertical components like columns and walls, whereas for the horizontal components, you can still make do with normal concrete. Now, the major issue as far as deploying this for mass scale housing is concerned is obviously you need to comply with building code requirements. Right now, there is absolutely no way that we can match the current building code requirements with 3D printing unless we do extensive testing on each and every structural shape and component that is being printed. So how do we actually do that? How do we standardize this process so that we can actually meet or create a set of standards with which such materials can be evaluated as being suitable for construction? And how do we integrate the utilities optimally? That could be something which we can plan a lot more before we actually get ready for mass scale deployment. And again, off-the-grid construction without supply chain support, how do we actually realize it? I know that I've said that in the previous slide, that we can actually get this material to far off areas which are difficult to access, but how do we really make it possible? There's a lot of logistical planning that needs to be done in the process. So there are also other challenges. Of course, many of you are aware that construction is an industry that is highly risk averse, and it is very cost driven, at least in our country, if not elsewhere in the world also, it is highly cost driven. Amongst consumers also, there's a fear of new technology. Very often, home builders, they are investing their life savings in building their own house, and they would like to see something which they are comfortable with, and they are sure that it will last them for a long time. If you bring new technologies to them without really showing them very clearly what are the benefits in the long term, obviously there's going to be some resistance to really adopt this new technology. There's a lack of an ecosystem currently for scaling up, because obviously we have not trained enough consultants, architects, and practitioners to see what they can do with this kind of a technology. Because this technology, as you all are quite aware of, is still mostly in the research stage. It's really not got out into practice as much. Again, regulatory approvals, how to obtain, how to actually set up these standard tests to get these approvals. And again, transportation infrastructure in our country could be lacking in several areas. One more aspect I need to also bring out is in countries where it has worked, for example, US, Germany, China, Netherlands, Spain, etc., the industry has really taken the lead in sowing the seeds for research. In India, the industry, as of now, has adopted a wait and watch approach. Of course, L&T, as I'll explain to you later, has also executed a project by renting a printer from outside. But again, they have not really gone full scale into the use of 3D printing for manufacturing. So again, we need to really realize that to come up to speed with taking this to the next level. So now let me just change gears a little bit and show you our journey in pictures, which will culminate in our house and my friend Aditya here will share a lot more about how this house was actually conceived and built. So we started off with very small scale printing. You can see this is a very small tabletop type printer which we were using, which had a simple screw based pump that was simply pushing the material through, down the nozzle. And we tried very interesting prints with here lime. This is basically lime, and this is clay without any cement in it. So again, 3D printing can make printing with other materials also possible, not just concrete. And you can see examples of very large scale projects also having been executed in clay. Earthen materials also have been used for executing large scale projects. This is the really start of our research, where we started looking at how we can fine tune the concrete mixture design to meet the demands of 3D printing. So we had to really go deeper into understanding what could be the aspects of rheology of the concrete mixture that we really need to understand and replicate each time that we prepare the mixture, so that each time that we do it, it is extruding from the printer in exactly the same way. So you can see here, we created materials, or we created blends of materials that were printed in these example structures, 3-layered and 4-layered walls. And you can see very clearly that all of them are keeping their shape properly. That means they are highly buildable. And the second is, as the new layer comes on top of the next layer, the previous layer still is able to retain its shape. Now you need to realize that when you're printing concrete, you can't wait for each layer to get hardened before you place the next layer. What will happen as a consequence of that is that you'll create an interface between the two layers, which will be very weak. So we don't want to do that. So we don't want to wait while printing. So as the first layer is printed and the printer nozzle comes back on top, the first layer below should still be fresh. That means it should not have hardened at all. Okay, but it should have gained some internal stress bearing capacity, which will allow it to take the load of the layer that is coming above without deforming. So that's basically the rheological control of the mixture, which we try to execute with some well-known parameters and well-known material combinations, which led us to really the right kind of design strategies. So we use this to try and print all these weird looking structures. Of course, most of these are square and circular elements, but these were our first trials that were executed somewhere in the summer of 2017. And we went on with these concrete trials all the way up to 2018, right? We had to really create ways of testing these materials, because this is not like conventional concrete. When conventional concrete is used in construction, we make these standard specimens, cylinders and cubes, and then get those tested in the laboratory. All that has been well documented, well understood, and standardized for people to accept the results. But here we are working with a material that is layered. So how do we design tests for these? Again, that's something which has not been universally accepted yet, but we were in the process of creating strategies by which you can actually test the strength of these layered structures. So these are some experiments that are describing the tests. And of course, a lot more has been published in research papers where we were looking at the characteristics of the concrete that was printed and the dependence of the concrete strength on the interface, right? Because you can imagine that even though you're printing fresh, that means you're putting layer upon layer while it is still fresh, because it is not jointed together by something like a compaction or a vibration, there's obviously going to be some level of interfacial effects that will play up in your overall strength attainment. So we were trying to understand in compression, in flexure, how does this material behave, and how to really undertake a characterization itself. Again, this is also showing you some additional tests that were being done. We also tried to look at whether we can actually understand, after the structure has been cast, can we pull off one layer from the other by doing a pull-off test and so on. We also experimented with different kinds of of shapes and combinations of materials, so that we were able to understand what are the limits with which we can, or what are the limits of our printing strategies. We then moved on to a slightly larger scale printer, which had a different sort of a printing mechanism. Earlier, I said in the small printer, we had a screw that was simply pushing the material continuously from one end to the other, so that we had a continuous flow possible. Now, in this case, we used a pump-based system to push the material to the nozzle. So you can see this pump is here. This is a primer which pushes the material into the pump. Once the pump is full, the piston of the pump basically moves forward in one stroke and pushes all the material out of this nozzle. And with that one stroke of the pump, we were able to push out about 75 kilograms of the material. Okay, so that is still a problem, because you want the material printing to be continuous. Now, in this case, when the material is getting pumped once the material leaves the pump and the pump is empty, there has to be a backward stroke of the piston to fill up the material, and then again forward stroke to push the material through. Now the issue with this is once you create an air gap in the pipe, the pumping will not be possible. You need to actually dismantle everything and clean up, and then only you can start the next layer. So with a single pump, we could only get about 60 kgs of print at single time. You can see a module here which is 3D printed, and that was done with a single push of the piston. Right. Another problem that the material experiences while it's going through this pumping. No, first of all, why did we move towards this pump system? The idea was to ensure that we are able to push concrete that is a lot stiffer. Because when you push wet concrete, this layer by layer deposition becomes very difficult because your material starts squishing or deforming. If your material is already stiff, when it's pushed out, it will retain its shape much better. So that's why we moved to this pump-based system, which was able to push out stiffer mixes. But in doing so, when you're applying pressure to push this material through the pump, there's also a possibility of the water simply separating out of the rest of the solids. So we had to design additional tests to ensure that the materials that we work with were able to resist that level of pressure. Now, using this 60 kilogram of material, just to show you a bit more detail about this pump, you can see this pump extruding the concrete out. And these are some trials with square-shaped elements that we actually worked in terms of the pump. So again, this is showing you the printing of these modular elements, which were about 60 kilograms. And these 60 kilogram elements were printed and then assembled together. Here you can see the assembly of these modules. Okay, this is one module, one half. This is the other half. Each half is about 60 kilograms. And these modules were then assembled, stacked just like a regular masonry structure to build up this simple room that we have just outside our civil engineering department. And we created this modular structure in September 2018. That was again technically the first 3D printed structure in the country. So in 1 year of work, we were able to build up to this level to build up a modular structure. But obviously, this does not. This does not really hold much water because again, having modules of 30 centimeters is good for such a small structure. But if you're going to build a larger structure, the idea would be to continue the printing until you reach the entire height. So we had to obviously move towards a larger structure. Of course, when we printed this, we popularized it with the Ministry of Housing and Urban Affairs. We had the Secretary of the Housing Ministry also come and talk to us in this workshop that we actually did. We also did a demonstration with them. They were quite happy with the progress we had made and promised to help us. Hopefully, this promise will be realized very soon. We also, of course, experimented with various structural shapes or non-structural forms also for furniture elements. You can see we've created these chairs and tables and other furniture elements, which looks quite fancy and can provide a new dimension to what you can actually do with 3D printing. Again, architectural shapes with overhangs and something that can be made possible without really much human intervention could also be prepared with 3D printing. Now, so we wanted to move to an industrial scale printer so that we could print much larger components. So this was the third printer assembled by Tvasta. And you can see this printer has, again, the same gantry-based system, but here the upward movement of the Z-axis could be able to print as much as 1.5 meters height. So using this was partially sponsored by L&T, and we were able to actually build a toilet module. I'll come to that in just a minute. I just wanted to show you the material delivery system. So these are two primers here. The idea was that these were connected to these two pumps, which are shown here. The idea is that while one pump is actually executing a backward stroke of the piston, taking in material, the other is doing a forward stroke and depositing the material into the pipeline. So while that completes its material delivery, the second pump is almost ready to continue without any breakage in the material supply. So with this, we are able to deposit a lot more material in a continuous tandem operation of the pump. So here you can see we conceived this toilet module that was to be printed entirely with 3D printing. In fact, even the slab and the roof were also printed by 3D concrete. You can see here the slab, bottom slab. This is the lower half of the toilet module, which is about 1.4 meters in height. And this is getting completely assembled using the printing. And this is the completed lower half. Of course, you see some white patches on the top. We were experimenting with a chemical that could be sprayed on the surface to speed up the buildup of the concrete, to speed up the structural buildup of the concrete. This is the upper half. As I said, we also printed the roof element. actually it's really no point in printing these horizontal elements, because it's much more elegant to make use of something which is readily available. A precast element would do as well as anything else. But again, the mandate from L&T was to actually print the entire structure without leaving any component. So we also left some gaps here, as you can see, for the pipes to be integrated with the utilities for the toilet. So just to show you some pictures of the construction of the house, I have given you all the fodder which led to the development of this construction of the house. Aditya will, of course, show you much more details of the house itself, but I'll show you what we did to actually enable the house construction. First of all, the printer itself was moved to a location where Tvasta had the ability to actually move it along one axis. So you can see here there are rails, and this entire system can be moved along the rails to actually print on 3 beds simultaneously. So there are 3 printing beds, which allows simultaneous printing of multiple elements together. So that's what they did. They printed all these multiple elements together. And you can see here they were stacked on the side and cured properly before they were taken to the site and assembled. Okay, so this way they were able to print these multiple elements in a fairly rapid pace. And these elements were then assembled. You can see the color differences that tells you the different elements that are there. So here, this is the bottom element, which is here, and this is the middle element, and that's the upper element. So you can see there are 3 elements that have been printed to take the entire height of the house. The lintels, you can see, are in precast concrete. So we just made these lintels with the same material that was left over after printing. We just used that to make these beams, and these beams were brought over to the site and put as lintels. So these are the assembled components. So you can see this part of the wall is nicely curved, and that brings in the right feature of the ability of 3D printing. Okay, so you can see here these are the assembled components, and we then did plastering just to ensure that we finally have a look that resembles a conventional house in all senses, but also integrated with these nice circular components. The roof was made in situ. The foundation also was done in situ, as you may have seen in the video that was shared in the invitation link. We also had the porch outside the main veranda, and that is also a curved element, but that is not 3D printed. That was again done in situ. So this is the completed house. Of course, you'll see much more interesting pictures from Aditya, and there are several locations where the plastering has not been done to give the user a glimpse of the actual wall structure that is outside. And this is a really impressive structure that's come out. Anybody who's visited the structure physically has said that this is probably the most glamorous house that they can see inside the IIT campus. I know that we have a long way to go as far as what is a concern to make them glamorous, but this probably gives us an opportunity to create something that is unique and interesting. But of course, I'm not going to give too much more in terms of pictures, which Aditya will share later. Just to summarize our journey, in 4 years, we have actually caught up with 50% of 3D printing groups around the world. The work so far, again, has been executed at a budget which is far lower than anything which has been done elsewhere. We have worked on a shoestring budget. Aditya will tell you more stories about that. But of course, if we really have to go big, we need to scale up from here. We need to make sure that our efforts are in line with the efforts that are made elsewhere in the world. How do we take this forward? The idea would be to come up with a 3D construction toolbox, because one should have some sort of a digital platform where a user is able to simply interact with the platform and choose from a variety of designs and methods to conceive their own individual structure. So client should be able to define the layout and the architectural sensibilities by which we actually do the construction. And the platform, the digital platform or the toolbox should be able to then break down into standardized modules. Why standardized? Because these standardized modules will be capable of getting joined quite easily. And if there's any need for putting reinforcement, that can be integrated quite easily into these modules. And again, manufacturing scale production can then be realized for the modules for speed, followed by curing and transportation to the site. So that will be the ideal way to actually take this forward, operate it in the precast type of a way, so that we can deliver printed components for assembly on the site quite rapidly. And that's the kind of thing that needs to be done. So in the future, with sustained R&D and support from the industry, and of course, alumni who are watching this video, we hope that it will be possible to realize these speeds that I have listed here, toilet modules for, let's say, Swachh Bharat Abhiyan within 6 to 10 hours, single-story house can be realized within 5 days, including the site preparation, the foundations, and everything. Multi-story buildings, at least up to G+3, can be realized with the existing technology in less than a month. And again, off-the-grid construction in remote locations, assuming we give the understanding for the logistics to be sorted out and so on. Again, in 2 years, I think we will be ready for mass application, provided we have the right financial backing and research support, which needs to be developed over the next couple of years. Right. So just to conclude, as I said, India's first 3D printed house was a culmination of 3 years, actually 4 years of research efforts. As I remarked at the beginning, it is totally Indian. The technology is totally Indian from start to finish. And I really have to give the credit to Aditya and his young team. The path ahead obviously is a tough one because we really need to scale up and standardize the production process to ensure that we can deliver on a scale that is demanded by our country. And just to give you some other highlights, several human resources were trained in this project. One of my PhD students completed his PhD and one PhD is ongoing. There's a dual degree student who joined Tvasta. This dual degree student, incidentally, was the one who stood by all the process of construction of the house. And I was remarking to him that no student of ours actually takes up a house construction as a project. So that was his dual degree project, to oversee the entire construction of the house. We also had several interns who got trained and MTech students who got trained in the process. Journal publications, several came out and several more are on the way. So we've had a very successful research and demonstration sort of a project. And I indeed am quite happy to be working on this along with my colleagues, Professor Koshi Varghese, Professor Ravindra Gettu, and Professor Benny Raphael. Together we have worked on many of these aspects, and hopefully the future will also have a lot of work in this realm for us. So I'll stop with that, and I think I've already taken up quite a bit of time, but I'm hoping that Aditya still has some time to share with you at least some more details about the house construction before we can take up the questions.
Thank you, Professor. And this was such an enlightening presentation. And we have more than 120 people online watching this, and everybody is enjoying this. And there are so many more who are going to be watching this presentation in future. Couple of questions, if you're okay to answer them.
Sure.
On to Aditya. Yeah. So some of the questions as they were asking, I think you had also answered. Some of that were use of steel as a reinforcement for the factory made structures. You have already answered that. And one question which had come repeatedly in multiple modes is, how much does it cost per square feet to construct such a
yeah, so see, this was a demonstration structure, and we learned as we were constructing it what are the difficulties in actually putting something together like this. Okay. So with this structure, the cost would have been definitely double the cost of regular construction. But I think once we get the hang of things correctly, and once we are able to execute it from start to finish with the kind of control that we want to exercise in this project, I think the cost can be brought down to something like less than 1,500 rupees per square feet. And given the time for execution combined with that cost, I'm sure that this will be a very good proposition for individual home builders also.
So there should be a lot of communication or collaboration with the construction industry for them to accept this as a model and keep going on, right? So is there some kind of a difficulty which you foresee when it comes to construction industry accepting this as a kind of a partial norm to also start building using this in their building structures?
Yeah, I mean, construction industry, as I said, is quite conservative in our country and everywhere in the world, to be precise, not just in our country. So a lot of the projects move forward when there's substantial support and standardization. And standardization is something which many projects bring up as a requirement for executing even new technologies. But they don't realize that to really create standards, it takes a fair bit of time and effort. So we have industry at our doorsteps asking for 3D printing of their structure, but they still want some standards to be followed, regular building regulations to be followed. And that's something which cannot be done overnight. One needs to really do a lot of work there to figure out the right kind of mechanisms by which we can standardize these sorts of modules also. So very often standardization and the resistance to new technologies and new ways of thinking can probably pose a damper as far as executing projects with 3D printing is concerned. But I'm hoping that with so many examples coming out and with the news feed basically being filled up with all kinds of 3D printed structures every day, I think the industry will soon come forward to really take this up in a big way, and that is really required. If you want to scale up, industry can give us solutions tomorrow. If we are left to find out solutions for ourselves, we'll probably take 2 years, as I said. But industry can definitely help us be on our feet as early as tomorrow.
You already have an industry leader like L&T supporting you. I'm sure others
Absolutely,
will
we
also
hope that
follow.
we'll be able to leverage their support a lot more in the future to really get ahead on this technology.
And maybe others can also follow their suit and kind of start with this
Absolutely,
as well.
absolutely.
And this also leads towards affordable housing, right, sir?
Yes, yes,
So, if we look at the Sustainable Development Goals of UN, we have affordable and clean energy, which is SDG 7, and then SDG 11, which is sustainable communities, which get satisfied by these 3D printed houses. But
right.
how about SDG 3, which is good health, and SDG 8, which is jobs? Will there be any effect on the jobs, and is there going to be any effect on the health of people who are going to be living in such houses? How accommodative are these houses for general janta?
Now, again, actually, what I have not added is we are going to be using this house, which is right now available in IITM campus, to monitor the indoor environment over a longer period of time. So that's something we're going to be doing for a long period of time. But again, the materials that are being used in this project are quite similar to what you use in conventional construction. So there is no reason to believe that health would be an issue in any way. In fact, the health of construction workers who will work on the site is far more affected by conventional construction because they deal with touching cement or concrete, which can be highly alkaline and can actually cause a lot of problems for the health of the people. Whereas in this case, you are getting a machine basically delivering the material and building up the structure for you. So that amount of contact can be avoided with the construction workers. Now, as far as the workers themselves are concerned, yes, the number of workers on site for construction are going to be much lower in 3D printed construction. So I'm not saying 3D printing is going to completely eliminate the need for conventional construction, but it promises to be a technology that will add to the range of potential technologies that are available for futuristic mass construction projects. So I don't think we should look at it to replace the existing construction industry. There'll be a whole huge market for the existing construction practices also. But then again, this is an added arrow that we'll have in our quiver that we can actually use for solving our mass housing problems.
Maybe upskilling the laborers will also be one of the opportunity with this kind of
Yeah,
building.
absolutely, absolutely. I think upskilling is something in construction industry that we talk about a lot. Unfortunately, because of the highly migrant nature of the labor, that often doesn't happen. And but if we are able to upskill and get them to the level that is required to handle such materials, to make these special materials, and so on, I think there's going to be a potential for creating additional jobs in that area.
Okay. Thank you, Professor. Thanks a lot for patiently answering all the queries. There
Most
are some
welcome.
more queries which have been coming here.
Sure.
Also, some of you have asked if you could visit the premises, but unfortunately, due to COVID scenario, will not be able to have a site visit. I hope once this is all cleared, will Taspa and the team be able to help us do
Absolutely,
site.
absolutely. The house is open for anybody who wants to visit, as long as as long as any lockdown is not there. Any of you are welcome to campus. Definitely, please come and visit and see for yourself the house that is being constructed.
That could be one more thing which IIT Mark can actually organize and have a site visit and
Yeah,
the.
we've had several visits already organized by IIT, and we've had alumni come in. We've also had other people from the industry. Aditya may tell you some more about them who have actually come and visited and seen the place and so on. Yeah.
Great, that's great. Okay, so now over to you, Aditya. We have Aditya here. Can you unmute and also? Yes. So
Sure.
we have
Yeah.
Aditya here with an amazing background.
Uh-huh.
Let me just put
Good.
his pin there. Yeah.
Yeah.
So Aditya, you're an alumnus of 2016 batch, and what made you come up with starting this company, and then what is your journey as far as this goes? How long did it take for you to go from conception to actually having this house built and inaugurated by our finance minister Shri Nirmala Sitaraman Devi ji. And
Right.
what is the team? What is your story? Can you just elaborate on all those things, please?
Sure, sure. So, yeah, thank you very much for inviting me here. And we started in 2016 as a company, 2016-17, but we had been working on 3D printing from much earlier than that. I am a 2016 graduate from IIT Madras, but we started something called the 3D Printing Club in IIT Madras, I think around 2014 or so. And our focus at that point of time was to really, I mean, bring in open source 3D printing technologies and make it popular among, uh, I mean, students in IIT Madras, because that was the first sort of 3D printing wave in India. And most of the technologies were related to plastic 3D printing. I'm a mechanical engineering graduate, so I had an interest in that area. And so, as a part of my dual degree project, we started to build an industrial 3D printer. Uh, this was called a selective laser sintering 3D printer, and that's how we started. I and my co-founders started this club. We started working together on that project, and then we started this company. At that point of time, the primary aim was to sort of enable industrial 3D printing to come up in India. We did not have a clear idea that we would be working in construction 3D printing. But then there was a conference that was organized at that point of time with industry, academia, and led by IIT Madras. Professor Manu was there, Professor Koshi was there. So I mean, that conference sort of kicked off this entire, I mean, idea of working on construction 3D printing. We thought that it was a very good problem to solve, and we were sort of pivoting at that point from being a consulting-led, problem-solving 3D printing organization to a more product-led organization which was offering a solution to the industry. So apart from the printers that we had already built, we started working extensively on construction 3D printing. We got a lot of support from Professor Manu and Professor Koshi in the initial days. And I mean, we started developing bit by bit of this technology. And it took us nearly, I would say, 3.5 years from where we started to come to this stage. So it's been a long journey. I think more failures than successes, but a few successes on our way. I mean, that we can really, I mean, show to the public. So that's how we got here. So maybe I'll just quickly walk you through a very brief, I mean, presentation that I have, just to give you a sense of our journey and how we got here. Hope you can see my screen. Yeah.
Yes, we can see this.
Yeah. So as I said, we started this company in about 2016, and our real aim at that point of time was to develop 3D printing technologies, not specifically for construction. And 3D printing essentially is a wide family of technologies, nearly 25 to 27 technologies coming under its umbrella. Everything sort of follows the same principle. That is, you build an object, a structure, or whatever it is, by adding material on top of each other, layer by layer. That's a fundamental principle of 3D printing or additive manufacturing. And we were working on a slightly different technology. And now, coming to construction 3D printing, we really had to focus on a few key elements, and we had these ingredients. So the 3D printer itself, the machine, that is something that we had expertise to develop. We all came from the mechanical engineering background. My couple of my other co-founders, they're also from IIT Madras, and they were, I mean, they're much more of engineers than I am, but they really had the network and the capability to design and manufacture these large machines. On the material side, we require a special type of material to 3D print large scale structures. And for this, we received extensive support from Professor Manu. We had support from a PhD scholar who was working under Professor Manu, named Rahul, who worked with us extensively. So I would say, I mean, this is one of a very good example of how a startup and an institution like IIT Madras can work together to build new technologies. It would not have happened without that collaboration, and that's something that we really, I mean, sort of take away from this entire thing. And we had to develop a new software for this entire 3D printing process to be handled. So the nature of the software is such that you can put in a BIM file or a building information modeling file, which architects nowadays are really familiar with. You can export a standard STL format from that BIM software. Any BIM software offers that. You can take it into the software. The software essentially takes a 3D file, slices it or divides it into multiple 2D layers. It could be anywhere between 15 layers for a 3D printed structure to 1,000 layers um, for a polymer 3D printed structure. So it divides that and then gives the code or gives the directions to the 3D printer to print the structure. So that's the process that the software does. And then you have printing strategy. So I would say these are the critical aspects of the 3D printing technology that we have built, and printing strategy is extremely important. So I get this question a lot. 3D printing has existed within the construction market for some period of time. Why hasn't it taken off? So I would say one reason is several companies in Europe who started developing this, and even in the US, did not have the ambition to really scale up. They developed very good technologies, but probably, I mean, they were not ready to sort of push it into the market with sort of hunger that should be displayed. In China, we have seen a lot of companies actually scale up, but I would say, I mean, companies in Europe have a little bit more advancement in the finer aspects of 3D printing. The companies in China have really taken it out into the open. They have a lot of support from the government as well. We hope to do that in India. So in India, the good thing about the group that we are working with is we have us, I mean, working from a startup's perspective, how to commercialize this, and we have support from institutions such as IIT Madras, which have really, I mean, the mindset to go into the depth and the fundamentals of developing this tech. So that's something that has been lacking in some of the other countries. So essentially, the vision of the company is to use 3D printing to automate construction to a very large extent. So we are trying to automate construction up to 80%, going beyond just 3D printing the structural aspect of a building. So we want to look at automating the plastering process, look at integrating the MEP elements, that is mechanical, electrical, plumbing elements into the structure during the printing process to an extent possible, and also look at reinforcement integration with the automation that is necessary. So essentially what we are doing is bringing digital construction or digital technologies to the construction realm. Probably for the first time, construction industry is one industry which has not seen any sort of penetration of automation or digital technologies at all. This cannot be said of any other industry. So which is, I mean, really a matter of concern, because if you look at the two largest assets that a person, sort of a normal individual who will own in their lifetime, I would say the first will be a house, second would be a car. So the automotive industry is developed to such an extent that it has become the backbone of Indian manufacturing or any country's manufacturing, and they've been able to make cars really affordable to the consumer. Whereas construction industry has really not been able to take that to the final consumer, and hence there is a little bit of a mismatch. And also one thing is technology-led construction processes, be it precast or any other technology, is really suited for large scale construction where builders sort of build extremely large apartment complexes or let's say infrastructure projects. Whereas if an individual is building a house or let's say any structure, a toilet, they do not have any technology to rely on. So this is something that 3D printing can solve because every aspect of this process is digital in nature. So the 3D printing platform that we have essentially built can cater to multiple types of structures. We can build anything from a small toilet module to houses. We're also looking at a few defense projects to work with the Indian Army. And of course, as Professor Manu showed in his presentation, we can uh, build furniture elements, facade elements quite easily as well. So it has wide varied applications. And three of us, as I mentioned, started this firm. I and a couple of my co-founders. We're all from IIT Madras, 2016. And it's been a real collaborative effort between IIT Madras and us. We started this organization called Imprint within IITM, which is IIT Madras Printability Lab. And the good thing is it's built in such a way that industries can come and work with us. We have worked with L&T, a couple of other cement manufacturing firms as well. Yeah, we are looking forward to more industry involvement. And we really collaborate with other institutions in India as Imprint to sort of take this technology further. So this is the 3D printed house. I mean, not completely finished, and this is the structure that we have fully built. So one good thing about, I mean, construction technologies is once you build it, you can really touch and feel it. And what we want to say about this particular structure is it does not feel different at all from a conventionally built structure. That might sound like a very different pitch from, let's say, I mean, anyone else who might be sort of talking about their product. But what is necessary for an Indian consumer, especially, is that they're able to trust their house or the single most a valuable asset that they will own in their lifetime. And Indians really trust quote unquote paka houses or concrete construction, or let's say brick and mortar construction. So one good thing about concrete 3D printing is we can build it with the material that they're familiar with, which is concrete. And once the structure is built, you really have to sort of go in really deep to figure out that it's a 3D printed structure. It does not look, feel, or sound any different. So we have had consumers come in, they knock at the walls and see whether it's, concrete. They sort of want to, know about the construction aspects, although they might not understand it because it's really important to them. So that's one of the key aspects of the structure that we have built. So these are a few pictures. I'll just take you through a video where I can explain to you how this entire process happens. So Professor Manu, I think, explained quite a bit with respect to how the technical aspect really works. So these are a few images of our factory. This is within Chennai itself. So just to give you a perspective from a video that we shot during the construction of the house. So as I said, we have left, spaces within the structure to just show that this is a 3D printed structure and not a conventionally prepared structure. It all starts with the proprietary concrete material. It is a special type of concrete, and we require a different concrete mixed design compared to conventional construction because we are not using formwork. And this concrete essentially has to bear its own load and take its own shape. I'll just show you that as we go forward. But it all starts with the digital model preparation, as I mentioned. So we load this 3D model, and then the printer completely acts on its own. So as you can see, this is a special type of concrete. Once it is deposited, it does not really, flow like normal concrete. It takes its own shape and it retains its own shape, because of which we are able to sort of build quite fast. And this is a production kind of a setup that we have in Chennai. So essentially, you print on multiple beds, and like a normal factory environment, we try to minimize downtime as much as possible. So once an element is built to some degree, we move to the next element, print on that, so that there is no deformation at the level. So once the element is 3D printed, we can easily sort of assemble it on site. Assembly takes very minimal time. And one of the key questions that we get is, have you used steel reinforcement? We have used steel reinforcement. It has been integrated during the printing process. So we pause the printing, integrate steel into it, and then sort of proceed further. So these are a few architectural elements that we printed along with the house. So as you can see, it looks exactly like a conventional structure. There is hardly any difference once we build it. And of course, this time we sort of finished it completely conventionally. That is, the plastering has been done conventionally, painting. Moving forward, we'll try to integrate as many of these processes during the printing process that we have. That is, we are trying to minimize as much site work as possible. So once the structure goes to the final construction site, it should be a very easy process to sort of put it together. And this particular process that we adopted is called offsite 3D printing. That is, we print at a factory environment, and then the elements are taken to the final construction site and then assembled. Our next project is in Pondicherry, and there we'll be attempting on-site 3D printing. That is, the final printer itself will go to the construction site and print right at the construction site. So there will not be any assembly that is necessary. But offsite and onsite are not mutually exclusive processes. That is, you don't have to choose one over the other. There are cases where offsite will be better. There are certain use cases where onsite will be better. Especially, in a crowded urban environment like India, we feel that offsite 3D printing will offer much more flexibility. But in certain rural regions, it might be much better to go with onsite, since we can avoid assembly completely altogether. So these are the 5 stages in 3D printing that I mentioned earlier. So one is the digital model design. Then we come to the slicing element, where our software sort of divides it into multiple layers and gets it ready for 3D printing. Then we have the material which is loaded into the printer. We have the printing process, and then we have the finishing process to get it to the final sort of shape that we want. So this is our 3D printing center, as you can see. So I just wanted to show you how the digital sort of architect's imagination looked like, and how we were able to sort of exactly translate into the final structure. So that's the magic of 3D printing. Exactly here, we have sort of explored certain curved elements and certain square elements just to show that for a 3D printer, it does not really make a difference whether the element is curved or straight. So we can print prismatic shapes with exactly the same level of difficulty or ease that we print circular shapes with. So that's why it's very easy for us to individualize construction. We don't have to go with boxy shapes, as Professor Manu mentioned. We can explore new types of designs. And people, when they build their houses, they want it to be built for themselves. So that's something that we can really do. So these are a few elements. I mean, in construction, I think many of the images were shown earlier. So the real problem that we are solving within the Indian construction industry is catering to the existing demand. So there was a question about jobs. So what is happening within the current construction space in India is you have a real need to build about 100 million houses or 10 crore houses by 2030, but you do not have the technologies to really execute it. And the government has a really ambitious plan to build about 2 crore houses by 2022. And there is a real lack of ability to really execute these structures on the ground because of the lack of technology led construction. And hence the government is pushing technologies like precast and 3D printing through building incubators and also giving projects early for these technologies to experiment with. Um, the government has also established is establishing an accelerator in IIT Madras to sort of help us navigate the regulatory pitfalls, etc. earlier. So this graph sort of explains why we need 3D printing or technologies like 3D printing within the construction industry. So while productivity has really gone up in every other industry, and especially in manufacturing, it has really sort of stagnated and even in some cases come down when adjusted for inflation over the past 50 years. So this is a graph of, I think, the OECD countries, but a similar case scenario exists in India. So precast, which was actually introduced into India by Jawaharlal Nehru in 1947 to accommodate refugees coming from West Pakistan, is still spoken about as a new technology in construction industry, whereas even in India it's 60 years old. And Soviet Union used it for post-war reconstruction quite extensively in the 1940s. So construction industry is very slow to adapt, and also I think it has been adapted only for large scale construction, not for individual construction. So reducing output and increasing productivity is something that we can really do. And solving the problem of affordability and also cost transparency is something that we really want to focus on. So I think, yeah, there is a time restriction. So I think I would like to end it with this. Happy to take any further questions that you have.
Yeah. Um, all right, great. Thanks a lot. That was a very interesting presentation, Aditya, and you had given us more insight into how this entire project came to be, because this is a long journey and it doesn't happen in 5 days as it is getting touted in the magazines and the news channels. There's a lot of hard work which your entire team has put for years together. Um, can I have a personal question? What is Tvasta? Why do you have the name Tvasta?
Right. So this 5 days that we are speaking about. So what happened is this particular structure, we built it in about, we printed it in about 21 days because it was during the pandemic and we actually had a cyclone, happening in the middle of that. Now, if we are asked to
Aditya, and the
print,
cyclone also.
yeah, and the
In
cyclone
the
as
middle of
well.
the cyclone also.
Yeah, we had a cyclone in the middle of our construction process. So, I mean, we can actually say that the house has withstood a cyclone even during construction. So, but now if you're asked to print the same structure, it would take us, for a 600 square feet structure, to print the elements, it would take us about 5 days. So that's, what we are capable of right now. So what does Tvasta stand for? So Tvasta is a Sanskrit word. It means to create something out of nothing. So there is a good analogy that we can draw with 3D printing to create something uh, new.
Through that, and this is fantastic. You both have been extremely patient, and thank you, Professor, for taking all the question which has come up in the chat and answering it all. Aditya was giving his amazing presentation here. So we had a great session, folks, with Professor Manu and Manu Santhanam and Mr. Aditya here from Tvasta, who explained the process in detail, the challenges, and what we can look forward to this in future. Thank you very much for this. I think we had a great session here, and kudos to your team. And we are all looking forward to come and see your work in progress, your factory, as well as the house which you have completed. Thank you.
Certainly, most welcome. Thank you.